I mean, right now, we're just learning basics. We're just adding numbers and subtracting numbers. So it's like literally like the first little box, like chunk box, the one that says arithmetic. Like that's where we are right now. Like we didn't get to the rest of that as yet. Look on the if you look on the algebra cheat sheet, look at where it says arithmetic. That's where we're at right now. Like basic stuff. You know? Yeah. So,
That's right. Or you put in parentheses, you have to treat it negative. So
exactly.
well, it's not parentheses, you're only gonna have to put the negatives.
Right.
So in this case, this one. Now,
No, we didn't get there yet. That's what we're doing today.
already see something like this. When you take this and this, that you do A of B, whatever amount, let's say like,
As long as it has the same
let's say, oh, let's say six plus six, 12, divided by six, let's say, the possibility hace two.
then you reduce it.
But if you divide the number, it's gonna be the same amount,
The same thing. Yeah.
because it's gonna be six between two is three, and then six between three and six, so two plus three is six.
That's true. That's all. That's all. So, no, too deep, too deep, too deep. Up is. All right, so let's jump into what we're doing today. All right. Again, if you feel like this is like, man, simple, no problem, just knock out your homework. All right, so we're going to talk about simplifying fractions. All right, basic stuff. So a fraction is a way to represent parts of a whole. The fraction 2 over 3 represents two of the three equal parts, as you can see in this figure. So in the fraction 2 over 3, 2 is called the numerator and 3 is called the denominator. All right. So numerator is the number on top, denominator is that number on the bottom, right? The line is just called a fraction bar, right? So this little circle, you could think of it like as a pizza, right? It's cut into three parts, right? And 2 over 3, this is two parts of the three whole, parts over whole. All right. So in the circle, 2/3 of the circle is shaded, two of the three equal parts. So fraction definition. So a fraction is written as A over B, where B cannot equal zero, right? It is illegal to divide by zero, right? And A is a numerator, B is a denominator. A fraction represents parts of a whole. The denominator, right, the bottom number, B is the number of equal parts the whole of the whole has been divided into. And the numerator A indicates how many parts are included, right? So fractions that have the same value are equivalent fractions. The equivalent fractions property allows us to find equivalent fractions and also simplify fractions. All right. Anybody have any questions so far? Just building a little vocabulary real quick. All right. We got to get the vocabulary up before we could get into like the deeper stuff, Uh-huh. Right.
They divide a whole number.
Yes. So let me give y'all the equivalent fraction definition real quick so y'all could get the idea. So this is called the equivalent fraction property. If A, B, and C are numbers where B does not equal zero, C does not equal zero, then A over B is equal to A times C over B times C. And the reverse is also true. A times C over B times C is equal to A over B. Right? It looks a little crazy, but this is how we reduce the fraction. We simplify it. All right. I got you. All right, let me explain and then we're gonna do an example. All right. It'll make sense by the time we get to the example. So a fraction is considered simplified if there are no common factors other than one in its numerator and denominator. So for example, right, 2 over 3 is simplified because there are no common factors of 2 and 3. But 10 over 15 is not simplified because 5 is a common factor of 10 and 15, right? So you see, if I have that 10 over 15, I can reduce that to 2 over 3, right? So we simplify or reduce a fraction by removing the common factors of the numerator and the denominator. A fraction is not simplified until all common factors have been removed. So if an expression has fractions, it is not completely simplified until the fractions are simplified. Sometimes it may not be easy to find common factors of the numerator and denominator. When this happens, a good idea is to factor the numerator and denominator into prime numbers, then divide out the common factors using the equivalent fractions property, right? Blah, blah, blah. That is actually how I simplify fractions, right? So I'm gonna be honest with y'all, keep it 100. I don't know my timetables, all right? So I gotta break up these big numbers into prime factors so I could get the correct answer, you know? Like if you ask me what goes into 315 and 770, I really don't know. Keep it 100 with you, right?
You know,
Mhm.
problems that we dealing with
Mhm.
are about simplifying and big equation.
Exactly.
So
Yeah.
like as we move forward with the other subjects, it becomes a common theme.
Right.
that
Exactly. Expressions, simplifying expressions. Mhm. Yeah, we gonna get deeper into that. So this is how you break up a number into its basic prime factors, right? You use something called prime factorization. So let me start off with 315, right? Just looking at 315, is there a number that jumps out to you that goes into 315? 5. 75 jumps out to you? Oh, wow, you smart. I'm with you. I saw 5. I didn't see 75. Maybe it does. I don't know. Maybe 75 does go in. But
Yes.
you just guess. All right, I'm gonna go with the 5 though, because that's the one I saw. Right. So we know that we could divide 5 into 315. I'm gonna cheat because I can. Right. So what is 315 divided by 5? Let's see. 63. All right, cool. Now, so now give me two numbers that multiply to give me 63. Yeah. Seven, 7 and 9. Very good, right? So this is 7 and 9. Now 7 is prime, 9 is not. Give me two numbers that multiply to give me 9. 3, right? So 3 and 3. So these circled numbers, these are the prime the prime factorization numbers of 315. So I'm just gonna do it up here just because of space. All right. So this is essentially negative what? 3, right? Times 3 times 5 times 7 over, let's do 770. Oh shoot. I don't know why I did that. And now it's not erasing. Oh Lord. Give me 1 second. What the hell? Okay. 1 second. Technical difficulty. There we go. All right. Give me two numbers that multiply to 770. What is it? 13? Really? What made you say 13? Oh man. 77 times 10. That's exactly what I was thinking. 77 times 10. Right? Just easy. Right? Now give me two numbers that multiply to 10. 5 and 2, right? That's good. Give me two numbers that multiply to 77. 11 and 7. Very good. Both of these are prime. All right. So on the bottom, what do I have? I have 2 times 5 times 7 times 11. Right? So what do you got to do after that? Right? Just cross out the like terms. All right. So what is on the top and the bottom that are the same numbers? Tell me. So I heard 5 and 7. That's it. Right? So now put it all together. I don't know why this acting so slow. Put it all together, and then that's your final answer, right? So this is going to be negative 3 times 3 over 2 times 11. Let's do the math on that. This is negative 9 over 22. That's the reduced form of this fraction. Make sense? Right? Now, I'm not saying every question gonna be like this. Sometimes you're gonna have a 10 over 15, and you could just tell by looking at it, oh, that's just 2 over 3. But when you don't know what to do, this is the way to go. Right here. One. And low key, this is how I do it because I don't know my timetables. Would you guys like to try one? Okay. Go ahead, try that out. So as you see, like throughout the class, we're just gonna mention all of those formulas on the formula sheet. We're gonna talk about it in great detail, but you guys will now know what all those formulas mean. All right, and you'll have them with you on your test. You'll have it with you on your final. You don't know how to do a question, just look it up. It's right there.
If it's not a prime number, I'm not done yet, right?
Right. It has to be prime.
I have to go down to that prime.
Right. And again, I highly recommend the 36X Pro, that calculator. Right? $20, on Staples or whatever. And Staples has this nice feature where they actually price match. So you could find the calculator elsewhere for cheaper. You could go to Staples and they'll sell it to you for that price that you found it at. I had this one student one time, they went into the computer and changed their location, right? So then they went to like Walmart. I don't even remember what state it was. One of the states that starts with an I, maybe Iowa or something like that, right? And then they found the calculator for $5, right? So when they went into Staples, they went on their phone and was like, "Yo, see, boom, well, they got it for $5."
Did you get it?
Yeah, they got it for $5. So I mean, it's legit. Like you go to the Walmart site in Iowa, which one was $5, so they price match. So So how we doing? We done? All right, let's take a look. Let's take a look. All right, let's start off with 69. Give me two numbers that multiply to give you 69. 3 and 23. That's good. All right. Now, what about 120?
12 and 10.
All right, so I heard 12 and 10. What else? Good. Good.
Same. Actually, the 12, 3 times 4, and then the 4 broken.
That's good. That's good. Yeah, yeah. Almost. Wait. So 6, was also 3 and 2, right? So now, what do I have? I have 3 times 23 up top. Now the bottom, what do I have? I have 1, 2, 3. So I have 2 times 2 times 2 times 3 times 5. So which number is the same on the top and the bottom? Not 23. The 3. That's it, right? So this is gonna be, I'm just call this negative 23 over the 2 times 2 times 2 times 5, which is, I have no idea. What's that? 40 maybe? Something like that. Yeah. Questions on this? Anybody?
Matter, as divided, it's same.
Right. Yeah, these fractions are equivalent, meaning like if you were to type them in the calculator, for example, and click enter, you would get the same answer out, right? The same decimal answer. But what I'm doing is I'm reducing the fraction, right? Go ahead.
That should be added to the this is top.
2 3s at the bottom?
Yeah, and 6. All that minus.
Oh, yeah. Got you. Yeah. So real quick, let's recap this. Just want to recap this real quick. Lord. Good computer. Good. Listen to me. Good. All right. So real quick, how to simplify fractions in 3 steps. This is how you do it, right? Step 1, rewrite the numerator and denominator to show the common factors, right? If needed, factor the numerator and denominator into the prime numbers first, right? Step 2, simplify using the equivalent fractions property by dividing out the common errors. That's the part where what number on the top is the same as on the bottom and you cross them out, right? And then step 3, multiply the remaining factors together to get the overall answer. Right? Any questions on this?
So I am doing a little bit, I'm simplifying the language.
Yeah.
So number 1, I'm showing how.
Right.
Second, a little bit.
Right. And whatever is left on the numerator and denominator together. Yep. All right, so if we're good, let's jump into our next task, multiplying and dividing fractions. All right. So many people find multiplying and dividing fractions easier than adding and subtracting fractions. So to multiply fractions, we simply just multiply the numerator and multiply the denominators. That's it, straight across. All right. Let me show y'all what I mean. All right. So this is fraction multiplication. If A, B, C, and D are numbers, where B cannot equal 0 and D cannot equal 0, then A over B times C over D is equal to A times C over B times D, right? So long story short, how do we multiply fractions? Just multiply straight across. Numerator with numerator and denominator with denominator. That's it, right? So it's multiply fractions, multiply the numerators, and multiply the denominators. All right? Simple, simple, simple. I just need to make a special note real quick before we jump into an example. And I just want to make a real quick special note, real quick. All right. So when multiplying fractions, the properties of positive and negative numbers still apply. Of course, it is a good idea to determine the sign of the product as the first step, right? So in the next example, we will multiply a negative by a negative, so the product will be positive. When multiplying a fraction by an integer, right? Integer is, just the whole number or whatever, which could be positive or negative, right? It may be helpful to write the integer as a fraction. So check this out. This is important right here. Any integer a can be written as a over 1. So for example, right, if you have the number 3, that's the same thing as saying 3 over 1. All right, that's a little hack, right? You switch it to a fraction, and now you know what to do with the fraction, right? Mm-hmm. So that's how you can convert a whole number into a fraction. All right, so check this out. I'm gonna show y'all an example real quick. Wait. Click it. Here we go. All right, so here's an example, right? I have negative 12 over 5 times negative 20x, right? And the goal here is I want to multiply these, right? Now you see that negative 20x, right? That's like it's an integer, but it's like a whole number, right? Put it over 1 becomes a fraction, and now you know how to multiply fractions, right? Numerator with numerator, denominator with denominator, and the question is done, right? So this is what I'm saying. I'm going to rewrite this as negative 12 over 5 times negative 20x over 1, right? And then just do what you know how to do. Numerator with numerator, denominator with denominator, multiply straight across. So help me out. A negative times a negative is a positive. Good, good. So the top is just going to be 12 times 20x. And then the bottom is just going to be 5 times 1, right? You know what? I shouldn't have used that. I should have went like this. My mistake. All right. Then just go ahead and just do it out, right? So 12 times 20x, what's that, like 240? Something like that? Over 5 times 1, which is 5. Am I right? 240? All right. But now look, I got 240 over 5. I could reduce that, right? So how many times does 5 go into that? 5 going to 24, 240. Feel like it's 48. Am I right? Okay. When I was guessing. Yeah, so, right, we know that this is 5 times 48x over 5. You could cancel these out. So your final answer would just be 48x. And that's it. Questions on this? Make sense? I could have broke the 240 down into all of its prime factors and just knocked out the 5, you know? Or I can do what you just saw me do, just pull out the 5 and then whatever's remaining, just leave it. It's not. Yeah. But that's all that's left. So you just leave it as 48x. Would you guys like to try one or do you feel like you understand it? You want to try one? No? Everybody in agreement? Y'all don't want to try it? All right. Again, there's no shame in wanting to try one. So now we're gonna switch gears a little bit. Kind of, sort of, a little bit. All right. So now that we know how to multiply fractions, we are almost ready to divide. Before we can do that, we need some vocabulary. So the reciprocal of a fraction is found by inverting the fraction, placing the numerator in the denominator and the denominator in the numerator. For example, the reciprocal of 2 over 3 is 3 over 2, right? Flip it. So when you hear the word reciprocal, flip it, right? Since 4 is written in fraction form as 4 over 1, when you flip that, it becomes what? 1 over 4. So the reciprocal of 4 is 1 over 4. Huh? This is the flip part, just the flip part. But we're gonna get to that in a second. All right. All right. So to divide fractions, we multiply the first fraction by the reciprocal of the second, right? Which is keep change flip. All right. So check this out. Check this out. Here's fraction division. If A, B, C, and D are numbers where B cannot equal 0, C cannot equal 0, and D cannot equal 0, then A over B divided by C over D is equal to A over B times D over C. This is keep change flip, right? Keep change flip. Keep the first fraction, change the division to multiplication, flip the second fraction, right? To divide fractions, we multiply the first fraction by the reciprocal of the second. All right. We need to say that B cannot equal 0, C cannot equal 0, and D cannot equal 0 to be sure that we don't divide by 0. Right. Always remember, it is illegal to divide by 0. Cannot divide by 0. All right. Check something. That's good. I'm sorry? Yeah. I mean, that's how it is. All right. Let's do an example real quick. I know y'all probably halfway done with y'all homework by now, but I got y'all. Also, remember for tutoring, right? The last day for tutoring for the week is Thursday. So there's no Friday and Saturday tutoring. There is Sunday tutoring though, but it's strictly online. All right? Right. No. Just Monday through Thursday. Yeah. But I'm just saying in case you wanted to do your homework over the weekend, I'm just saying like there's no tutoring Friday and Saturday, so just wait till Sunday, you know? Yeah. Yeah.
Well, we don't have to, like, the homework office today, we don't have to do it. We have like homework.
You have a lot of days, yeah.
Okay, that's
Yeah,
good.
yeah, yeah, yeah,
That's
yeah.
important.
Yeah, yeah, yeah. Just get it done when you can, you know. But like I do want y'all to be able to have access to help while y'all doing your homework, you know? So yeah. All right, so here's a question right here, right? It says find the quotient. This is -7/18 divided by -14 over 27, right? So very simple, right? We're gonna keep change flip, right? So you're gonna keep the first fraction. This is -7/18, right? I'm gonna change that division to multiplication. Right, I'm gonna flip the other one, right? So this has become -27/14. Y'all gotta help me out with this now. A negative times a negative is what? Positive. Good, good. So then very simply, my answer is gonna be what? +7 times 27 over 18 times 14. All right? I'm not gonna lie to you, I don't really feel like reducing this. So I'm gonna show y'all a trick that you guys can use, right? Y'all know that 7 is prime. We don't need to touch that, right? But we could break down 27. We could break it down from right here when it's more simple than making it a bigger number and breaking that down, right? So 27 is like what? 9 times 3, something like that, right? And then 9 is 3 and 3, so this is like what? 3 times 3 times 3 times 7, right? That's the top. You can do the same thing with the bottom, right? 14 is what? 2 and 7, right? 18 is what? That's 9 and 2, right? But you know 9 is really 3 times 3, right? So this is times 2 times 3 times 3, right? All right, help me out. Which numbers are the same on the top and the bottom? All right, so I got a 3 here. 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 What else? With a 7 here and a 7 here. I can't knock out that other 3 because there isn't a matching 3 on the bottom, you know? Yeah,
And it's like for
yeah.
example, one at the bottom.
Right. They have to match. Yeah, yeah. So now what's left over? So 3/2 times 2, right? So 3/4. So that's another way you could do it, right? You could just break up the numbers that are already broken, right? And then cross out the like terms, boom, boom, boom. And whatever's left over, there's your final answer.
Dividing columns, multiplication.
Right, right.
And then I use the other.
Yep.
You use that, do you ever have to simplify?
Because this is a simplified version, 3/4. So you're good. Yeah. Would you guys like to try one? Huh? Y'all quiet today. Y'all can say yes, you know. All right. All right.
You use that.
Exact same way. Yep. Mhm. Today's not gonna get much harder than this. I mean, after this, we're just doing adding and subtracting, and then that's it. You know, so we could do examples. Y'all got time if y'all want.
question.
Go ahead.
So using the technique, right?
Mhm.
So what if we, well, let me show you.
Yeah.
What if we get this?
Perfect. The top is just one.
This one?
Yeah, that's it. Yeah. How we doing? Everybody got it?
I said, oh, wait, I got.
Awesome. Awesome. All right. You got it? So let's try this. I have -7 over 27, right? Keep change flip. I'm going to keep that fraction. I'm going to change the division to multiplication. I'm going to flip the second fraction, right? So this becomes what? -36 over 35, right? And then we said a negative times a negative is a positive, right? So we know right off the bat our answer is going to be 7 times 36 over the 27 times 35. Right? No, same way. But again, what I said, we could break this down, right? So let's break that down. 6 times 6, and we can go a little bit better than that, right? So we could do 2 times 2 times 3 times 3. That's 6 and 6 times 7. That's our numerator, right? Denominator, what do we got? 27 is what? 9 times 3, right? So let's do 3 times 3 times 3. And 35, what's that? 7 times 5? Something like that? Something like that? Yeah. So 7 times 5. Now here's the question, right? Which numbers are the same on the top and the bottom? All right, so I heard 2 threes, boom, boom, and a 7, right? Boom, boom, right? So that's it. So let's see what we're left with, right? It's gonna be 2 times 2 over the 3 times 5, right? Let's call that 4 over 15. And then that's it. Yeah, that's what happens when you don't know your timetables. You gotta do stuff like this, you know? Yeah.
My dad.
Yeah. Right? I'm faking it up here, man. If I could fake it, you can fake it. Nah, you know what it was though? Like all jokes aside. So I'm over here in like elementary school, right? So I'm learning my timetables, right? And back then we go up to 12, right? Then we got some question like, oh, what's 13 like times two? No, that's not on the timetable list, right? Then they show me how to do it the long way, like 2 times 3. Once I found that out, I'm like, I don't need to memorize this. I could one way it all the way through. Yeah. 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 Oh wait, you can't forget 9. Nine is Gucci. Yeah. 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 Also, all the answers of 9 add up to 9. That's another thing. You know? So not if you do like I'm about to say 9 times 3. That's not what I mean. Well, yeah, 9 times 3, right? 27. If you add 2 and 7, you get 9. That works for all of it, you know? Like any 9 times table, the answer has to sum up to 9. Mm. Nice little tricks. I feel you.
Put my best.
All right. So let's get into the hard stuff now. I promise you, it's not too bad, but this is the hard stuff right here. So we're gonna be talking about adding and subtracting. Oh Lord, here we go. All right. So when we multiplied fractions, whoops, hold on one second. When we multiplied fractions, we just multiplied the numerators and denominator and multiplied the denominators right straight across. To add or subtract fractions, they must have a common denominator. All right. So fraction, addition, and subtraction. If A, B, and C are numbers where C cannot equal 0, then A over C plus B over C is equal to A plus B over C. And also, A over C minus B over C is equal to A minus B over C. So to add or subtract fractions, you add or subtract the numerators and place the result over the common denominator. All right? That's the sauce right there. So the least common denominator, LCD, of two fractions is the smallest number that can be used as a common denominator of the fractions. The LCD of two fractions is the least common multiple, LCM, right, of their denominators. All right. In English, I got you. I got you. Let me get an example out. You'll see. Yeah. You might notice also today's homework is a lot less than yesterday's. Mhm. Uh-huh. The one before, it was 4/15. Yeah. Mhm. Got you. It'll still work if you do it the long way, you know?
Or how my brain works, it's better if I do it alone.
Okay. That's fair. That's fair. Up a little bit. I'm sorry. Like, you want to see this part?
Yeah.
Okay. I saw another hand somewhere. Go ahead. Yeah.
Well, see, like, regular semester.
Hmm? Yeah.
Felt like I was
It was too easy.
all the time.
Yeah. Yeah. I got you. I got you. It might be a little bit less though. Cause like I don't give like all the questions. There's some questions I don't agree with, you know? Like for example, there's some questions there where it's multiple choice, and I'm like, I don't want to give you that because I'm not gonna give you that on test, you know? So I wanted to match what you would get on your test, you know? Yeah. And also it's like it's overkill. Like you see how many questions is there already. Huh? Yeah, they do.
Yeah.
I don't even know that. Yeah.
Some of them is one,
Yeah.
some of them is like four questions in one question.
And one. Got you.
So I have a question.
Mhm.
So how are we gonna put it in the thing to show that it's a fraction?
So some questions they break it up where they have like a box for the numerator and they have a box for the denominator. And then there's also some questions where you just have to put the fraction like 5/6, which means like 5/6, for example. Mm-hmm. So let's talk about it. The least common denominator. The least common denominator, LCD, of two fractions is the least common multiple of their denominators, right? So after we find the least common denominator of two fractions, we convert the fractions to equivalent fractions, right? With the LCD. Putting these steps together allows us to add and subtract fractions because their denominators will be the same, right? That's the key. That's the key. All right, let's look at an example real quick. So I have 7/12 plus 5/18, right? So what do I want to do? I want to find the LCD, right? I want to find the LCD. In other words, I want to get a denominator that is the same so that I could just add the numerators and call it a day. All right. So let's check it out, right? Let's say I have 12 and I have 18. Now, I'm gonna show you guys a really, really easy way to do this, right? Take the bigger number, 18, right? Let's start off with 18. Can 12 go into 18 evenly? Nah, right? So I know right off the bat, 18 is not the LCD, right? Just start off with the bigger number, right? Double 18 now, right? So 18 times 2. What's 18 times 2? 36? Is it?
Yeah.
36, right?
Both times.
Yeah, just times 2. The 36, right? Does 12 go into 36? That's your LCD done. Right? So what am I saying? You start with the bigger number. Does the next number go into it? If the answer is yes, the bigger number is the LCD. You're done, right? If it doesn't go into it, times 2. All right, does it go into it? Cool. If it doesn't go in, times 3, times 4, times 5, right? Until you get that number that it goes into. That's it. Yeah. Yep. So here's the hard part. 12 times what number is 36? What is it? 3, right? But look, you got to be fair, right? What you do to the bottom, you got to do to the top. Hold on one second. You got to be fair. What you do to the bottom, you got to do to the top, right? All right, we said 18 times what was 36 again? I forgot. 18 times 12 is 36? 2, right? But you got to be fair, right? What you do to the bottom, you got to do to the top. And then that's it. What's 7 times 3? 21, right? Oh, shoot. I didn't mean to write that. 21. Plus, what's 5 times 2 again? 10, right? All of that is over 36. Now, what's 21 plus 10? What is it? 51, 31, right? So this is 31 over 36. I'm done. That's the answer. Yep. Any questions on this? No, this might be a little new. 36. So I took the largest number, right? Between the two denominators, it was 18. You're welcome. This makes sense for everybody? Do y'all want to try another one or y'all feel good? Another one? All right. A little bit harder, but I feel like y'all could get it. We got 7 over 12 plus 11 over 15. Actually, no, I can just keep it like that. Hopefully I can see that. Good. Anybody need more time?
Yeah.
Okay.
Okay.
Good. Let's try this out.
So,
So, first thing I need to do is I got to find that LCD, right? What is it?
10 multiplied by 11.
11. Okay. Let me see. I have 15 and I have 12, right? Remember, always start with the bigger number. So 15 times 1. Is 12 going to 15? Nope. So that's not it, right? What about 15 times 2, which is 30? Does 12 go into 30? Nope, that's not it. All right, 15 times 3, no problem. This is 45. Is 12 going to 45? Nope. Right? All right, let's try another one. It's gonna be like what? 50, 60. Does 12 go into 60? Right? That's it. LCD is 60. Right?
No, so it might be 11. So it's like,
Yeah. So here we go. 11 over 15, right? Let me switch up my colors real quick. All right, so 12 times what number is 60? 5, right? Remember, I got to be fair. What I do to the bottom, I got to do to the top. 15 times what number is 60? 4, right? But I got to be fair. What I do to the bottom, I got to do to the top. So after that, 7 times 5, what's that, like 35? Plus 11 times 4, what's that, like 44? Of course, all over 60. And we just want to add these together. What's that, like 79, something like that?
yes, you said that.
I'm just guessing. I don't even know. Ugh. Now, there's another idea that you guys can use as well, right? Let's say, for example, I'll use the same question again, right? So just bear with me 1 second. 7 over 12 plus 11 over 15, right? All right. I know I want to add these together and I want to get the most simplified answer, right? But let's say for some reason, right? I don't know how to do this LCD thing. I'm on my test. I want to get the right answer, but I don't know how to do the LCD, right? There's another idea that you could use called a common denominator, right? So I'm dropping the L. I'm just calling it CD, right? Common denominator. How do you do the common denominator, right? This is how. You see over here, you got the 15 in the other term. Just multiply the 12 by 15. What you do to the bottom, you do to the top. You see how you have 12 in the other fraction? You're going to multiply the 12 by the 15. What you do to the bottom, you do to the top. And you go through the same process. You're going to multiply them together, add those numbers together. This is going to be a massive fraction. I'm not going to lie to you, right? But once you have that massive fraction, you can reduce it, right? You could break it down to its prime factors, cross out those prime factors, and get the final answer, right? So this is another method that you could use, right? This is called CD. Say it again. I'm sorry. Exactly. Exactly. Yeah, so that's the common denominator. This is if you don't want to find an LCD. So when you use the LCD, right off the bat, your final answer is going to be the simplified answer, right? But if you don't use the LCD, if you use this method called the common denominator, you're going to come out with a big answer, right? Like a big fraction, but simple. Just break it down, prime factors, cross out top, bottom. Whatever's left over will be the final answer. That's it. All right. You want to do it? All right. 7 times 15, what's that? What is it? 90? I don't even know. Let's see. 105. Let's see what 12 times 15 is. It's 180. Plus, what's 11 times 12? I should know that. It ain't 132, right? No, it's 121, right? 131? Hold on. Oh, this bad. This one of the timetables we should know. 132, yeah. Over the 180. And then we're gonna add these together, right? So what is that? That's like 237, something like that, over 180. All right. Second. Yep. So now just prime factorization, prime factor it out. So I'm not gonna lie to you. I'm looking at 237 and I have no idea. Right? So what you do, take the number, right? And then just divide it by prime numbers that you know, right? One of them should go in. So let's say 237 divided by, let's start off with 3. Oh, wait, it worked. That was a guess. I promise you, it was a guess. I had no idea. All right. So this is just 3 times 79, right? And then the bottom, 180, right? Let's see. What's 180 divided by 3? Is that 60? Something like that? 3 times 60. Now, how did I know to stop there, right? I believe 79 is prime, right? Let me see. If I took 79 divided by 3, I feel like 3 don't go into it. I know 5 don't go into it. Um, Let me see. 13, I don't think goes into it. Um, but I'll try it anyway. I don't think 17 goes into it either. Uh, yeah, so 79 is prime. So that's one way I could tell to stop at 60, right? Kill the threes. So 79 over 60. I knew that was the answer, but just to justify why I'm not breaking 60 down further, right? Yeah.
I know.
Huh?
Nah.
Yeah.
LCD is better than CD.
Yeah. So your choice, LCD or CD?
What country?
Same answer.
Oh,
Yeah. 79 over 60. Yeah. It's just different. That's all. All right. Give y'all some notes real quick. Little procedure. All right. So this is how to add or subtract fractions, right? Step one, do they have a common denominator? All right. Common denominator means the same denominator, right? If yes, I'm just going to jump to step two. If no, then you have to rewrite each fraction with the LCD, the least common denominator. So find the LCD or the CD, right? Change a fraction to an equivalent fraction with the LCD as its denominator. Then now you can do step two, add or subtract the fractions, the numerators, right? And then step three, simplify the fraction if you can at the end, right? And that's it. Questions on adding and subtracting fractions, anybody? Good? All right. Not bad, not bad, not bad. Little recap real quick. Real quick, real quick. So we now have all four operations for fractions, right? Here's a little table that shows you everything, all right? This would be a nice picture to take if you want. So fraction multiplication, A over B times C over D is equal to A times C over B times C. Simply multiply the numerators and multiply the denominators together. All right. For fraction division, you have A over B divided by C over D is equal to A over B times D over C. Keep, change, flip. Simply multiply the first fraction by the reciprocal of the second, right? Fraction addition, if you have the same denominator, A over C plus B over C is equal to A plus B over C. Add the numerators and place the sum over the common denominator, right? So your answer is going to be placed over the same denominator. Fraction subtraction, A over C minus B over C is equal to A minus B over C. Subtract the numerators and place the difference over the common denominator, all right? So to multiply or divide fractions, an LCD is not needed. To add or subtract fractions, an LCD is needed, all right? So just so we clear, right here, LCD needed. LCD needed. All right? For multiplication division, no LCD. Okay, there you go. All right, let's do an example real quick. Also, when starting an exercise, always identify the operation and recall the methods needed for that operation. Good advice. Yay. All right. Here's an example. So this is two questions, A and B. All right. So for question A, a second. So I got 5x over 6 minus 3 over 10. All right. So just to recap, what do I need to have in order to do the subtraction? I need to have the common denominator, right? So I have 6 and 10. What's the common denominator? 2. No. It's going to be a larger number that both of them go into. What is it? What is it? 60 is good, but there's one better than 60. 30. All right. So 6 times what is 30? 5, right? What you do to the bottom, you do to the top. 10 times what is 30? 3, right? What you do to the bottom, you do to the top. So here goes your final answer right here. 5 times 5 is what again? 25, right? It's 25x, right? Minus, what's 3 times 3 again? 9, right? All over 30. Boom. I'm done. That's it. All right. How about for part B? Let's go with the BCC green, right? So I got 5x over 6 times 3 over 10. What's the answer? Mm-mm. How do I multiply fractions? What do I do? Yeah, that's what the dot means. Straight across, right? So help me out. 15, right? 5x times 3, right? It's going to be 15x over 6 times 10, which is 60. Reduce it. 15 goes into 60 how many times? Not 5. Close. No. 4, right? So this is what? The top is 4x. And then this is, wait, what am I talking about? The top is 1x and the bottom is 4, right? So final answer is just x over 4. Huh? There's a 1 there, but 1 times anything is itself, so I don't really mention it. Huh? Yeah, yeah. So that's it. Just 1 over 4.
Yeah, no question.
Mm-hmm.
What number of people the three?
The 3, it multiplied. 3 times 5 is 15. 15x. And then I reduced it. 15 goes into 64 times. All right. So eventually, when you get more advanced at it, this is how I want you to do it. Just knock it out, reduce it, you know? You can still use your other tricks that you learned earlier. All right.
You throw the over LCD and LCD not needed.
Yeah. There you go.
Go back to the
Also, this is on your formula sheet, just letting y'all know.
the early wedding, right?
Uh-huh.
The difference says negative 6.
Well, that one is the minus, so that's why I had to do the LCD. But B didn't have that. Yeah.
Okay. Can you
Mhm.
go?
You want to do another one?
No. Oh.
All right. So I have 5x over 6 minus 3 over 10, right? In order for me to subtract them, I have to have the same denominator. So my first thought is, what is the LCD, right? You could use 60, but 30 is a better LCD, right? Start off with the 10, right? Is 6 going to 10? No. Double it. 10 times 2 is 20. Does 6 go into 20 evenly? No. Triple it. 10 times 3, 30. 6 goes into 30. So that's why the LCD is 30. And then you just have to make these denominators that you were given in the beginning to 30. So 6 times 5 is 30, but what I do to the bottom, I gotta do to the top. So that's why I multiply the bottom and the top by 5. 10 times 3 is 30, but I have to multiply the bottom by 3. So what I do to the bottom, I do to the top. All right? Then you just multiply the top numbers. 5x times 5 is 25x. 3 times 3, that's 9. And that's it. They can't be combined because of the variable that's there, right? If it was like a whole number, like say it was like just 25 minus 9, then I could actually subtract those numbers. But because there's a variable there, they can't be combined. So they stay separate like that. For B though, right? I can multiply the numbers together, right? So, and how you multiply fractions is straight across. Numerator, numerator, denominator with denominator. So 5x times 3, boom, 15x. 6 times 10, boom, 60, right? And then you just reduce it, right? You could have, if you wanted to, show you another method. Wait. Let's say I had 5x over 6 times 3 over 10, right? Another way that you could have done this, you could have reduced the fractions diagonally before multiplying. So you could say 3 goes into 3 once, 3 goes into 6 two times. 5 goes into 5x 1x time, and 5 goes into 10 two times. Multiply straight across, 1x times 1 is just x, 2 times 2 is 4. That's another way you could do it. You can reduce it diagonally before you multiply straight across. Right? That's another method. You guys want to try one or you want to move on? Move on? All right. There's more in the homework, so don't worry. Go ahead.
So we can multiply variables and whole numbers, but we can't add variables to whole numbers.
No, because they're different terms. All right. Yeah. We'll get into that later on in the semester. All right, last topic for today. Same last topic we had yesterday. All right. So we're gonna evaluate variable expressions with fractions. So we have evaluated expressions before, but now we can evaluate expressions with fractions. Remember, to evaluate an expression, we substitute the value of the variable into the expression and then simplify it. All right, let's try it out. Let's try it out. So look, I got 2x squared y, and I'm going to find the answer when x is equal to 1 over 4 and y is equal to negative 2 over 3. All you have to do is take the value of the variable and plug it in. So this becomes what? 2, open parentheses, what's the x? 1 over 4 squared times a y, which is negative 2 over 3. That's it, right? Just do the math the way you know how to do it, right? You guys remember PEMDAS, right? So what's the first thing I'm gonna do? Not the parentheses. I mean, yeah, parentheses, but what's the next thing after that? Exponent, right? So what's 1 over 4 squared? What is it? No, no. So 1 over 4 squared. To get that answer, you square the numerator and you square the denominator. So what's the answer?
8.
Huh?
2/8.
No, what's one squared? Huh? 1, right? And what's 4 squared? 16, right? So 1 over 16. So this becomes, I remember with the whole number, right? I'm gonna make the whole number as a fraction. 2 over 1 times 1 over 16 times a negative 2 over 3. Right? How do we multiply fractions again? Straight across, right? And we know a positive times a negative is a what? Very good, right? So this is gonna be what? 2 times, let me do the dot, times 1 times 2 over 1 times 16 times 3, right? So trying to think, how do I want to tell you guys about this? I don't feel like breaking up the 16, but you guys know that 2 times 2 is 4, right? And we know that 4 goes into 16 how many times? 4, right? So I'm just gonna cross these out, right? 1, 1. I'm gonna cross out the 16. I'm just gonna make that 4. So this is just gonna be what? Negative 1 over 4 times 3. Call that negative 1 over 12. And that's my answer. Questions about that? The idea from this was just to take whatever they give you as an answer, right? X equals this, Y equals that, plug that into the expression that they give you, and then just solve it, right? That's it. The homework questions are not this hard, just the in-class stuff. Does this make sense, or do you guys want to try one? You want to try another one? All right. All right, try it out. Same kind of question, right? Just take the value of the A and the B, plug it in, evaluate it. Right? Everybody good? All right, let's go over it real quick. So I have 3AB squared, right? Let's rewrite this. So this is going to become 3 Instead of the A, I'm going to plug it in. So I have negative 2 over 3 for A times B, which is a negative 1 over 2, and then squared. Right? PEMDAS, we're going to square this, right? What is negative half squared?
Still negative.
Negative half squared. Not, it won't still be negative because a negative times a negative. Positive, right? So what's the answer? Huh? 1/4, right? So this becomes, I'm going to make the 3 into a whole number. I mean, into a fraction. It's going to be 3 over 1 times negative 2 over 3 times positive 1 over 4. Right? And a positive times a negative times a positive. Go ahead. Huh? Kind of. Not really, but kind of. Yeah. It's going to be implied. Put it like that. It's going to be implied. So this is going to be negative, as you guys said. And then how do we multiply fractions again? Huh? Straight across, right? So the top is going to be what? It's going to be 3 times 2, right? Times 1. And the bottom is going to be what? 1 times 3 times 4. Is there anything on the top and on the bottom that's the same? What is it? 1 and 3, right? So let me cross them out. I got the 1, 1. I got the 3, 3, right? And I can reduce the 2 and the 4, can I? 2 goes into 2 how many times? 1 and 2 goes into 4 how many times? 2, right? So here's my final answer. Negative 1 over 2. And that's it. Questions about this? Huh? Good, good. All right, so that's it for today. You know, I'll hang around for a few minutes if you guys want to start your homework or right ahead. If you finished your homework, you're free to go. All right. Come sign the attendance though before you leave right here. All right. May I take this down? Is anybody still copying? Can I take it down? It's good? All right. Appreciate y'all.